Hello, my name is Hollis Darby with Army Signal Training, and in this video we're going to be covering port security. Now, this is going to be video 1 of 2. In this video, we're going to simply cover the theory of port security because there's no sense in going into the configuration of it if you don't understand what it is. So I highly recommend that you take notes and you learn this information before you carry over to the configuration video. So, port security basics. Port security is a switch security feature that allows us to control and or limit the number of MAC addresses learned on a switch port interface. And we do that with something called the maximum command. And we'll be covering all this a little bit later, but we use something called the maximum command to define the number of MAC addresses I will allow that switch port to learn. So let's use Fast Ethernet 0/1 on my switch as an example. What I can do is say, hey, you're allowed to learn up to 2 MAC addresses. And it will learn up to 2 MAC addresses. On the event that a third MAC address comes across, what'll happen is there'll be a security violation that's imposed on that interface, and depending on how we had that configured, depends on the action taken. But what I'm doing is I'm limiting the number of MAC addresses that switch port will forward, which is exactly the intent behind port security, and it's exactly what we want to use it for. The next thing is it can be configured to limit a particular switch interface to a set number of dynamically learned MAC addresses. Now that kind of goes into what we were just talking about with the MAC address. We have a few different ways of assigning secured MAC addresses. But one of the options is dynamically. So instead of specifically going in and statically defining, I can just say, hey, I'm going to allow you to learn up to 2 MAC addresses. And the first 2 MAC addresses that come across that switch interface, it's going to dynamically learn. And that will be the only 2 that it's going to listen for. The next thing is it can be configured to limit an interface to a particular MAC address via static assignment. So instead of allowing the switch to dynamically learn this, I, as the administrator, go in and dynamically assign the MAC addresses I want it to forward for. It's also all this is useful for protecting against a CAM overflow attack. And what a CAM overflow attack is this. A switch can only learn about so many MAC addresses. And depending on your model of switch and the resources you have available to that switch will depend on how many MAC addresses it can learn. But for an example, let's say it can learn 3,000 MAC addresses. What happens if I shove 4,000 MAC addresses into it and kind of force it to try to learn 4,000? It is going to take my very expensive, $2,000 switch and turn it into a very cheap $2,000 hub. And the whole reason why we got away from hubs, there's multiple reasons, but one of the reasons why we got away from hubs is because hubs are really a security issue for us. Because if I send out traffic on one interface, I don't want every interface on that device to receive it. That's a huge security concern. But that's exactly what a CAM overflow attack does, is they basically take your really nice switch, overflow it with MAC addresses, and turn it into a really expensive hub. And that's something we want to prevent. The other thing is it's used primarily on user-facing interfaces to protect against end users plugging in unauthorized rogue devices on their network. So here's a scenario. Bob has a computer on his desk and he gets to the network via an Ethernet cable, right? Bob is really tired of being tied to his desk. He wants to roam around his office and not be, confined to his desk to do his work. So Bob has a bright idea. He goes to the store and he buys a cheap wireless access point. And he brings it to the office and he hooks it up into that Ethernet cable on his desk. Well, now Bob has wireless capability. But what Bob has done is create a huge network vulnerability or security vulnerability on your network. And he didn't do it necessarily maliciously, but he doesn't know any better. So the way we can prohibit Bob for doing such a terrible act is to control what MAC addresses can be on that switch port. thus eliminating the possibility of Bob hooking up a wireless access point to the interface and it working. So let's define your secure addresses. What are your secure addresses? You configure port security on a per interface basis. So if I have devices on Fast Ethernet 1 through Fast Ethernet 5, I have to go into each interface individually or use the range command to configure port security. But you need to know it's on an interface by interface basis. And what you do is you define the set number of trusted MAC addresses to be learned on the port. So I have to provide it with the knowledge base of, hey, switch port F0/1, this is how many MAC addresses you're allowed. And we do that by utilizing the switch port security maximum command. Now, there are kind of three flavors of secured addressing. We have static, we have dynamic, and we have sticky. Static is manually configured by the administrator. Addresses are added to the secure MAC address table, but also in the running config, which means when the administrator saves the running config, that static assignment is now in the startup config. So it kind of binds it to the configuration file. We accomplish this, the static assignment, by utilizing the switch port security MAC address followed by the MAC address itself. Now with dynamic assignment, the switch automatically learns MAC addresses on a port up to the maximum of allowed MAC addresses defined by the switch port security maximum command. The addresses are added to the secure MAC address table dynamically, but will not be stored in the running config, thus it will not be stored in the startup config. So at any time, if your switch loses power or you restart your switch, it will have to dynamically learn those MAC addresses again. And remember, this is on a first come, first served basis. So if we define up to 2 MAC addresses to be learned, whatever the 2 first MAC addresses that come across to the switch port interface, those are the 2 that it's going to dynamically learn. And we accomplish this by utilizing just the switch port security command. So we don't add any other special character to it. We don't add the MAC address followed by the specific MAC address, and we don't use the MAC address followed by the sticky command. We solely use the switch port security command, and that allows you to dynamically learn up to the maximum you've defined. Now the third and last option we have is the sticky command. And like the dynamic, sticky can learn the MAC addresses automatically or dynamically. But unlike the dynamic, sticky will add the secure MAC addresses to its running config, which thus, once you save your running config, binds it to the startup config, and it will stay with you even during a power outage and or a switch reload. And the command to do that is switch port security MAC address sticky. Now, we need an action to occur if something was to violate this policy we're defining. And we have 3 options to us. We have protect, restrict, and shut down. Now, protect, this is the least severe of the 3 options we have available to us. As frames are learned from an unauthorized MAC address, they are simply not forwarded and sent to null 0, which is the trash can. So when I utilize the violation protect command, and we're authorizing up to 2 MAC addresses, right? And it's already learned those 2 MAC addresses, and a third random MAC address ingresses into the interface. All it's going to do is throw that traffic away, and that's it. Which might be your intended purpose, but it's not the best option available to you. The next option is restrict. It operates much like the protect option and the fact that it drops the unauthorized MAC address traffic, but it will also generate a syslog message and also increment the security violation counter. So, unlike protect, that simply just throws away the traffic and that's it, restrict will throw away the traffic, but also notify you that this action has happened. And the last option we have available to us is shutdown, which is my favorite and also the default if you don't predefine it. And in this option, it is the most severe of the three. The option will put the port in an error disabled state. And from the error disabled state, the only way for the port to come back online is for you, the administrator, to go into that interface and initiate the no shut command, followed by the no shut command or no shutdown command. And the only alibi to this is using automatic recovery features, which we'll talk about here shortly. So what the violation does as a whole is we predefine a maximum number of MAC addresses will allow our switch to learn. And then we follow that up with the way we're going to allow it to learn it, whether it be dynamically, sticky, or statically. But once it learns the maximum number of MAC addresses allowed, we have to impose a violation mechanism to basically not penalize, but have a way of enforcing our policy. And by default, if we don't predefine, protect, or restrict, it's going to default to shutdown, which as it gets that third erroneous MAC address into the switch port, it's just going to error disable the port altogether. And if we use restrict, it'll notify you and increment the security violation counter. And if we use protect, it will do nothing. The automatic recovery feature. Now I will say, if you're using, switch port security in a rather large network, let's say you have, a couple hundred or 100 users, utilizing port security might be your worst nightmare. And the fact that mistakes are going to happen, and they're probably going to happen more often than you think. And that is exactly why we need to utilize port security. But it could really tie up a lot of your time and having to go into these interfaces and constantly shut the interface down and then initiate the no shutdown command and bring it back online. So what we can do is utilize some automatic recovery features to kind of do this for us. So automatic recovery features. If a secured port goes into the error disabled state due to a port security violation on the interface, the administrator would typically have to go in and initiate that shutdown, no shutdown command. But we can automate this process by issuing the error disable recovery cause psecure-violation, which stands for port secure violation, followed by the error disable recovery interval and however many seconds. Those two commands there, the two error disable commands, are done from global configuration mode. And what it allows us to do is this. It's simply what it's telling you is this. If a port security violation occurs, recover that interface after X amount of seconds. So let's say I do 600 seconds. That's 10 minutes. So what will happen is a user makes a mistake and plugs his laptop into the wrong interface or whatever it may be, putting an unauthorized laptop on the network. It's going to shut down that interface. But what happens as soon as that goes into an error disabled state, it starts this recovery interval. And after 10 minutes, it will dynamically or automatically unshut that interface for you. Which is it's pretty convenient, and it still gets our point across that we're still prohibiting that rogue device or unauthorized device on our network, but we also don't have to go in every single time a user makes this mistake and no shut their interface. Now, depending on your intent of your network, you might want to be notified that this action has happened. Maybe you have a secret squirrel network that you don't want unauthorized devices connected to, and if that's the case, don't provide a automatic recovery feature, because what that forces is the user to personally have to come to you and say, hey, my port's not working anymore, or I don't have connection anymore. And once you go into some of the show commands that we'll be covering in the following video, you'll discover that, oh no, they plugged an unauthorized device in our network, and thus you can take follow-on action. But that's all that's the introduction to port security, the theory of port security. I would really make sure that you understand this before you follow on to the configuration video, which I'll be releasing shortly. But other than that, I hope you enjoyed the video and have a good day.